Alright, so let's see what we got here. So these first few should have been pretty straightforward. And as we've hopefully remembered and started to notice from general chemistry, when it comes to Lewis structures, we should start to see a lot of patterns. That the same atoms almost always need the same number of bonds. So nitrogen with its 5 valence electrons generally needs 3 bonds. Oxygen, 2 bonds. And most halogens have 1 bond. So that's what we see in these first 4 examples, is that we're going right across the first row of the second row of the periodic table and going from 4 to 5 to 6 to 7 valence electrons. Alright, C2H6. So the first thing we know is the carbons are going to have to be connected, because the other atom in this molecule, the hydrogens, each only get 1 bond. From there, we can just fill in the hydrogens all around. Same thing for C3H8. We connect the 3 carbons and fill in the 8 hydrogens. Alright, then as we go from number 5, which is C2H6, to 7 and 8, we start taking hydrogens away. As a result, what will that do to our carbons? Well, carbon needs to still have 4 bonds. Carbon always has 4 bonds. And so as we take those hydrogens away, we're going to end up with double and triple bonds. Now in number 9, did you connect it as carbon, carbon, oxygen? Or as carbon, oxygen, carbon? Which would give us that molecule. Or did you go carbon, oxygen, carbon for this slightly different molecule? So which one's correct? Well, they both are. Both of them have 2 carbons, both have 6 hydrogens, and both have 1 oxygen. In addition, all of the atoms have an octet. So both of those are correct answers. So does this mean that sometimes we can have more than one chemical formula, or more than one structure for a given chemical formula? The answer is yes. And that's something we'll get back into in lecture in a little bit. The other thing you might notice here is that I didn't draw any of the lone pairs in on oxygen. Now, I can go ahead and draw them in, but what you're going to start to see in the next little while, definitely by the end of chapter 1, is that often things like lone pairs, if we don't need to put them into a drawing, we often just leave them out. And finally, number 10, C10H22. The key here is we know that the carbons need to all be connected to each other because they're the only atom in this molecule that can have more than 1 bond. And I went for sort of the most basic molecule we could draw, which is just a straight line of carbons. But you could have drawn these carbons in any arrangement, any connectivity that you wanted. And as long as you had 10 carbons and 22 hydrogens and none of your carbons exceeded 4 bonds, that would have been fine.